Algebra 2, Unit 1, Lesson 4 is called Using Technology to Work with Sequences. So what I need you to do is I need you to open up a Google Sheet. So click into your email and navigate to Google Sheets. If you don't know how to do it, it's kind of in the same place where you would go to Google Classroom. You would just click on Sheets. You could also use Excel, or you could also use I believe it's called Numbers, but Google Sheets will be the easiest thing. So, all right, so here's my sheet. I gave it a title here. I titled it Illustrative Math, Algebra 2, 1.4. You don't have to do that because we're just going to delete it. Our learning goal is I can use a spreadsheet to create a sequence. So here's my spreadsheet. I'm going to click to the warm-up. So in cell A1, I'm going to type 2. I click right here and I type in 2. A2, I type 3. -10. And then instead of 1/5, I'm going to use 0.2. It's the same as 1/5, but the reason I'm going to avoid the 1/5 is because the Google Sheets wants to convert that to a date. It wants to make it January 5th. And we don't want it to recognize it as a date. So rather than changing the settings, I figured it's easier to just use a decimal. So here I'm going to type equals, make sure you put the equals, A1 plus A2. Okay, that's in cell B1. So you can kind of see how it's B1. They're highlighted there. So what do you think is going to happen here? If I add A1 plus A2, it's going to be 2 plus 3. It should be 5. Okay, so I'm going to just, there you go. And the next one I hit equals A3 times A4. And you can see right there, it highlighted those. So -10 times 0.2 should be -2. Hit enter, there you go. I'm going to type in here equals, don't forget the equals, B1 plus 333. So B1's 5, 5 plus 333 should be 338. And the last one, I'll type in equals abs B2. Now I didn't put the equal sign because I want you to see what happens. It doesn't work, okay? The formula doesn't work. So I got to put equals abs B2. And now it'll take the absolute value of whatever's in cell B2. Okay, so I'm going to go over here and I'm going to start typing my response. So B1, B2, B3, B4, where do they come from? Well, it's a combination of the numbers we entered into A1, A2, A3, A4, and the formulas we typed into B1, B2, B3, B4. Okay. Now, if I change the numbers, obviously we're going to get different things. Like, let's say I change this 3 to a 4 and hit enter. So this obviously changes. That becomes 6 because 2 plus 4. And then B3 also changes because B3 was B1 plus 333. Okay. I'll put it back to the 3. If I change one of these, A3 or A4, that's going to change B2 because B2 depends on A3 and A4. So if I just change this to, I don't know, let's say 2. 2 times 0.2 is 0.4. So there you go. And then it also changes that one, B4, because B4 depends on what's up here in B2. Okay. All right. So what happens, obviously, values in B1 through B4 change depending on which cell we changed in column A. All right, not always, just depends on the formula. All right, new formulas. Can you figure out how to raise a number to a power? What happens if you forget to start the equal symbol? So we already kind of answered B. So I'll leave a blank for A. B, if we forget the equal sign, the formula will not work. Right? So let's try a different one here. Let's do this one. Let's type in this row or this cell equals how to raise a number to a power. So could I do, let's do A2, and then I'm going to hit the caret button. So I got to hit Shift 6. Let's say I want to raise it to the second power. So it should be 9 if I hit enter, which it is, okay? What if I wanted to change that? So I could come up here and change it, or I click up there. Let's say I want to raise it to the third. So 3 to the third, 3 times 3 times 3 should be 27, okay? So let's try a different formula. What if I wanted to, take a cell, let's do equals A1 plus A2. Let's say I want to put parentheses here. Let's say I want to multiply those cells. I wanted to also multiply that times the sum of A3 plus A4. See what happens. Up in cell invalid cell. What if I put a times in between them? Might need a times there. There we go. It'll add these two right there. Then it'll add those two, and then multiply them. So cool. So we did a little experimenting there. Raise a number to a power. Yes. Use the blank button. Okay. Use the caret button. All right. Moving on to the next thing. All right. Open a blank spreadsheet in A1. Type 10 and enter. So there's a couple ways you could do this. You could go down. Well, you could add a new spreadsheet, or you know what I could do? I could just click on each cell and delete everything if you want. Might be easiest. All right. In A1, type 10 and hit enter. In A2, type equals A1 plus 3, would be 13, all right? Click once on cell A2 to highlight it. See the little plus in the bottom right? So I got to move my cursor down there to the bottom right. Click and drag it several rows. So what's kind of cool is it keeps adding 3. So this one was plus 3. And then if you look here, plus 3, plus 3, plus 3, plus 3, plus 3. It kind of created an arithmetic sequence, okay? Which is kind of helpful, kind of neat. So I'm going to fill in here what happens. All right, so in this case, it continues to add 3, and it creates an arithmetic sequence with a common difference of 3, an initial term of 10. All right, what simple thing can you add in column A so the sequence shows 12, 15, 18? So as you look at 12, 15, and 18 here, you can see that these values, 12, 15, and 18, those are still plus 3, okay? So all I got to do is change the first number here to 12, then it should adjust everything. Okay, and it did. All right, so here, I'm just going to write down here. Change A1 to 12. Okay. What simple things can you edit so column A shows the sequence 12, 11, 10? So we need to change A2. We need to change the formula to A1 minus 1. Okay, and then but the problem is I got to re-drag it down. And there you go. It'll subtract 1. If I don't, if I just leave it, it's going to still be adding 3. Okay, so here we can change A2 and drag the plus sign down. Okay. All right. In B1, type 16 and press enter. B2, type equals B1 times 0.5. Okay. Click the little plus sign and drag that down. All right. So what this did was this here created a geometric sequence. Okay. First term, A1 would be 16, and then your common ratio would be 0.5. Okay, if you look here, you're multiplying each term by 1/2. So I guess I already kind of described it, but I'll write it over here. This term equals 16 and ratio of 0.5. All right, what simple thing can you edit so the column B shows 10, 5, 2.5? So your common ratio is still 1/2, because if you look here, 10 times 1/2 gives me the 5. So all I got to do is change that first term to a 10. And there you go. All right. Keeps the same formula, so everything gets changed there. So here. So this time we want to keep the 10, but we want to multiply by 3. So change the formula to B1 times 3. Actually, we need an equals. And drag the plus sign. Okay, and remember the plus sign comes from the bottom corner, so bottom right corner. Change that to times 3. Hit enter. So it did not change the other one, so I got to drag it. And there you go. All right, so it's basically kind of been creating a geometric sequence for us, okay? All right, in column C, starting at C1 and going down, type these terms of a geometric sequence. So 700, 70, 7, 0.7, 0.07. Right, in cell D2, we're going to divide them. So we're going to type in C equals C2 divided by C1. And we get 0.1. So 700 divided by 70 equals 0.1. So if you notice there, that's the same as your common ratio. If you take 700 times 0.1, we get 70. And then we continue timesing by 0.1, we get the next term, we get 7. So it would look something like this. So 777. If you look here, this is times 0.1 times 0.1 times 0.1. Okay, it ends up being our common ratio. So the result here is our common ratio. And then if I fill it down, it should be the same all the way through. So I'm going to drag it down. Okay, now the last one was 0 because I don't have a number in this cell. Okay, so it's really like doing 0 divided by 0.7. So I could probably get rid of that. Okay, so there you go. So my answer here is it's always 0.1 because the common ratio is constant. Okay. All right, in column E, starting E1 and going down, type these terms of the arithmetic sequence. Whoops. 1, 5, 7, 10.5, 14, 17.5. In cell F2, type equals E2 minus E1. That's going to give me 3.5. And then I'm going to fill it down. Oh, you know what? The last one, I only can fill it down twice because I only typed in. Oh, shoot. I missed that. I was supposed to start at 7. Whoops. 7, 10.5, 14, 17.5. There you go. I'll drag that down 3 spots. So anyways, I get 3.5. So what's the result here? So obviously 10.5 minus 7 equals 3.5. And the meaning is going to be our common difference of the arithmetic sequence because it's adding or subtracting. It's kind of like this. You start out with 7, 10.5, 14, 17.5. And it's like, okay, if I do 10.5 minus 7, just like those numbers right there, it's the same number that you're adding. Okay, so if I go ahead and answer this question, we always get 3.5 because the common difference constant in an arithmetic sequence. Okay. Kind of neat. All right. Use the spreadsheet to decide whether the sequence 8, 12, 18, 27, 40.5 is arithmetic or geometric. Okay, so here's what I'm going to do. I'm going to just come down here. I'll type those numbers in. 8, 12, 18, 27, 40.5. Okay, so if it's arithmetic, in this cell, I need to type equals. I got to do this cell minus the cell before. So A17 minus A16. And if I drag it down, I should get the same number if it's arithmetic. So those numbers don't match up, so I'm going to say not arithmetic. Okay. I'm going to go over here and check if it's geometric. I have to divide the numbers now, so I hit equals, and I start with the second one. divide by the number in front of it, hit enter, I'm going to drag it down. If I get the same number, since that number is constant, when we divide it, we could say it's geometric. Okay, so the answer is geometric. Okay, now if I wanted to do this like with pencil and paper, all I got to do here is write them out. So if I write it out here, 8, 12, 18, 27, 40.5. All I'm going to do is I'm going to start with the second number here, this 12, and then subtract 8, so I get 4. And then I go to the 18, and I minus the 12. I'm always subtracting the number in front. And I see here that I'm just going to stop there because I see that they're not equal. Okay. If I want to check if it's geometric, I divide. So 12 divided by 8, 18 divided by 12, 27 divided by 18, 40.5 divided by 27. Now, it doesn't look to be the same, but if I reduce all those and make them exact numbers, I'm going to get 1.5 all the way across, or I guess 3/2, depending on how you type it in to your calculator. But you can see that it's geometric. Okay. Now I got a new one here. So I'm going to change my numbers. Now it's going to give me some weird values here, but that's okay. I'm going to just type them in. It'll if I can keep the same formulas, if I put them in the same place. Okay. So this one here, I don't need that one. I'm going to delete that because I don't have as many numbers. I had 5 numbers there. So in this case, it is arithmetic, and in this case, it's not geometric. All right, so we're going to go here and we're going to write down here it's arithmetic. So it's rate of change or growth factor. In this case, our rate of change, or in other words, the common difference equals negative 7.9. I guess up here, I mentioned it, but I didn't write it. Our growth factor, or common ratio, equals 1.5. Okay. All right. Open a graphing utility and follow your teacher's instruction to create a new table with 2 columns. Learn how the 2 numbers in each row can be plotted as points in the coordinate plane. Okay, so I'm going to open up a new sheet here in Desmos. Okay, so I'm going to hit this little button here that says table. And what I'm going to do here is I'm going to just use like 0, 1, 2, 3, 4, 5. If I want them in the same line here, as long as this column, as long as I add the same value, okay, I'm just going to add 3. So I'm going to start with 4. I'm going to add 3 to every one of these, okay? And if I look over here, what happens? They go in a straight line, okay? So with the positive slope, all right? So there's my first table. So now we want a horizontal line, so all of these values have to be the same. I'm going to change them all to 4, okay? So the x's have to go up by the same value, so I just picked going up by 1. And then the y's have to all be the same. That gives me a horizontal line. Change the numbers so it does not represent a function. So here we need to have you know, you can put any random number here. The only thing you need here is you need to have a couple of the same. Oops, hold on. You have to have some of these with the same x value here, having different y values. So what happens is, if you look over here, those 3 points are stacked on top of each other. So when I have different inputs, I get different outputs. Or I get the same, hang on, let me say that again. Or the same input, I get different outputs. So this fails the vertical line test. So if I were to draw a vertical line through those points, it would fail, okay? All right, for number 2, make one column a function of the other, okay? So different steepness. Okay, let me go back here. I think I started with 4 and then I went up by 3. Oh, I got to change these numbers back. All right, so different steepness. Let's just go by 2. So let's change this to a 6, to an 8, to a 10, 12, to a 14. You can see it's less steep. And then maybe if I even go by 1, there it is, less steep. All right. So if they don't lie on a line, so maybe I multiply. Let's do this. Let's start with 2, and let's multiply by 2. 4, 8, 16, oops, I should put 16, 32, 64. All right, so you can see here, I'm going to move this over here. They don't lie in a straight line. They make like kind of like a curved type of graph there, okay? All right, see, change the table so that some of the points are plotted in the second quadrant of the graph. So I need to have a negative x and a positive y. If I'm in this quadrant, the x's here are negative, the y's are positive. So I'm going to change these to like negative, whoops, -2, -5, -6, -7, -8, and then all of these are positive, so we're good, okay? I'm just playing around with plotting points here. Okay, so how do you create a table of values using technology? You're going to type them in. Type the values in the formula that you need. What are some advantages of using technology to find a rule for a sequence and extend the number of its terms? We can very quickly create a sequence. When do you think it's appropriate to use technology to represent data or to calculate statistics? I would say when dealing with a large array of values. Okay. All right, I can use spreadsheets to create many terms of a sequence. I can use technology to graph a sequence. All right, last thing, the cooldown. Use a spreadsheet to find the first 5 terms of a geometric sequence that starts with 625 and has a growth factor of, oh, there's no number here. Let's just say a growth factor of 1.2, okay? So I'm gonna go back here to my sheet. I'll come over here to column G. So it starts with 625. Oops, let me go up here. 625. And then this term is going to have to be equals G1 times 1.2. And I got to drag it down. So I have 5 terms there. Okay. Here's a sequence. 111, 103.8, 96.6, 89.4. All right, to decide if it's arithmetic or geometric, arithmetic, I have to divide, arithmetic, I have to subtract. So I'm going to subtract H2 minus H1, and then I need to drag it down and see if this value is constant. Oops, I only dragged it down one spot. So since that value is constant, when I subtract, we're going to say arithmetic. Okay, so here I'm going to say arithmetic. All right, this one we're going to subtract. This one we're going to divide. Can't be both, so it's not geometric. If you want, I can show you here. I'm just going to go up to my formula and I'm going to change that minus to a divided by up there. Hit enter, and then I'm going to re-drag it down. And you're going to see that they're not equal. Close, but not. All right, what are the next 3 terms? So let me go back here. Let me change that to a minus. So our common difference is negative 7.2. So I think I could just drag this down. Next 3 terms. Oops, nope, I can't do that. That won't work. I got to go back here. And I have to drag that down. No, that's not right. Oh, you know what? It's okay, then I'm making a couple mistakes here because you're seeing how not to do it. What you could do here is you could put equals this cell minus 7.2, and then I could drag that down and get the next ones. I forgot that we typed them in. We didn't get them from the formula. So there you go. There's the next 3 terms, A2.2. Okay. All right. So that's it for today's lesson.